So for our fifth problem, let's try this one. Samantha and Donna are building a pipe for their arts and technology subject. To do so, they devised a cylinder 8 inches high and 6 inches long, okay, in diameter. A hole with a diameter of 3 inches is drilled through the pipe. The density of the steel they were working with was 490 pounds per cubic feet. So what is the mass of the pipe? What's the mass of this pipe when the smaller pipe was removed? When this was removed. So how can we remove it? How can we solve this problem after this pipe has been removed? Of course, it's gonna be a very simple problem. We can use the volume for finding. We can use the volume of a cylinder to find the exact volume of this pipe with the smaller pipe removed from the given cylinder that we have. So therefore, the volume of this one is just gonna be the volume of the pipe is gonna be the volume of the cylinder minus the volume of the hole that they made there. So this is gonna be pi r squared h minus pi r squared h. And this is gonna be pi times the value of r, the big one, the big cylinder first. So that's gonna give us 3 squared multiplied by 8. And what's 1.5 squared? So that's gonna give us 2.25, okay, multiplied by 8 times pi. And what's 2.25 times 8? That's just gonna give us 18 pi. Okay, and what's 72 pi minus 18 pi? So 72 minus 18, that should give us 54 pi. So therefore, the volume of the pipe, okay, the volume of the pipe is equal to 54 pi. So now that we know the volume, we can use the formula for finding the mass of a given figure by multiplying the volume, okay, and the conversion factor that we have here, and also the density of our given figure here. So we're working with a steel working with a material for this pipe that is a steel with a density of 490 pounds per cubic feet. Okay, so to solve for the mass of our given cylinder here, so that's just gonna give us the mass is equal to 54 pi times the conversion factor. But since we don't know yet the conversion factor, let's leave it at that. And then the density is gonna be, yeah, so this is 54 pi cubic inches. So let's just write the symbols, cubic inches. And this is gonna be 490 pounds per cubic inches. So how do we solve for the conversion factor? So we know that 1 inch, okay, so we know that 12 inches is equal to 1 feet. So therefore, 1 cubic feet should be equal to 12 cube. There you go. It should be equal to 12 cube in order to get the cubic inches. And what's 12 cube? That's just equal to 1,728. That's just equal to 1,728 cubic inches. And that's going to be equal to 1 cubic feet. So therefore, our conversion factor here is going to be 1 all over 1,728 1,728 cubic inches. And therefore, our cubic inches here, they cancel out. And therefore, the mass is going to be 54 pi all over 1,728 times 490, okay, cubic inches, pounds per cubic inches. Okay, so there you go. So that's also gonna cancel out for this one. So therefore, the mass is gonna be, okay, 54 pi all over 1,728, okay, and then multiplied by 490. So that should give us 48.11. Okay, so therefore, the mass of our given figure here is equal to 48.11 pounds. Okay, so the mass of the steel, okay, the steel figure is 48.11 pounds. And that's the answer to our problem, and that's how we solved it.